Hello, this is Zhang Jiyin. I'm doing COSC 60 by 70 final project presentation. The problem of project will be illustrating the database of Ticketmaster and discover relationship of user, venue, event, and so on. Currently, Ticketmaster has over 115 million active users worldwide, and there will be more users processing those data in order to manage the data of Ticketmaster, you are using databases technologies to develop the system of managing users' data such as purchasing tickets and users. The importance will be finding each database relationship will help Ticketmaster knowing that event popularity such as sporting events, concert, and other things. This is data resources. I found these data resources on the website so that one over 100 million users data will be properly managed. But how they will manage the data? This is the data description here. So the data will include variables and this is the relational graph. The event table has ID, name, type, local data, value, information, and user ID. And the user will have ID, name, email, and column. And the venue new name will have name, location, capacity, address, city, country, state, and postcode. The payment information will have type billing address, card number, CVV number, first name, last name, expiration date, and card event ID. Under the price information, we have seat number, seat availability, seat resale, seat price, seat area, column, and the user ID. And the queue information, we have name, type, user, and waiting time. Waiting time. This is the relational graph. The user is in the queue, and the user would this will show how user can enter the venue, and this relationship showing that users and price. Whether user can go to the price information, and the users can go to event information, and the user can go to the payment information if they successfully enter the queue and got ticket. This will be the queue of this will be the relational graph. It's queue. This is all the variables, and it will show the relationships and the user and venue and event, and the event has queue. User are going to the queue. User are going to the event. User are going to the venue, and user are having the price and the unit payment and the user. This is a database solution. So Ticketmaster might be using Neo4j to make a directional graph as similar to the graph shown, similar to this. For example, on the left side, there might be the user. The person can be user. User can enter the queue. The squad might be the value of queue. The tournament will be the event, and the team will be the venue. And the parties, and the person might go into the price list and going to pay the price for the note. And this might be the venue information, country, region, venue, city, and continent in order to show the information about what how the concert are in the popularity of this. And then here's my MapReduce solution. They have input about the MapReduce because they have a lot of original data such as credit card CVV number, first name, last name, email, and card type. And those are very, very combined. Those digits are very combined. Sometimes they won't match the correct information. So the input are a very mixed data. So we need to split it into those several rows. And then we will make maps on card ending number. There are there are 5 card numbers, card ending numbers. There are 6 CVV code, and there are 6 first names, and last names, 5 last names, and I might have emails, and they have card types, and they will combine and reduce and showing the combined, reduced, and reorder the data here, such for the correct name, email, the card number, and the card type, and in order to keep those data in security. So they are if the card has not in the security numbers, it will impact the data safety. So then the next reproduce will show that event every event worldwide. Those are managing event where event occurs. Those are event name, location name, time name, and attendant name. They might be very complex. So they are going to split into several groups, like event. Event will be an event group. Location will be location group. Time will be time location group, and attendees will be another group. And the map will be map event A to F, and the location will be A to B, and the time will be from time A to F, and different attendees name are numbers from A to F, and we are going to combine them, into different order, because have they might have wrong information, so they need to rearrange that. So location also will have in very we need to arrange them, and the time they need to check every databases in order to get those in order, to make sure the time and the attendees are the same area, so that the data will be correctly managed. There are the advantages of Neo4j. The Neo4j will provide real-time analysis of concerts, sport events, and the popularity of this. Neo4j can handle billions of nodes, which are users such as users' name, email address, venues, and events. The MapReduce will process the data in way of parallel processing, and we can split a huge amount of data, and it can sort different types of nodes. There are some disadvantages of managing mark logic. Managing mark logic data need a lot of time, and the data are very complex to manage, since it will be more difficult to manage as like Neo4j and MapReduce, and it might making facing risk of data security, and the maintenance will be very high compared to Neo4j and MapReduce.